Well, I'm not sure who's listening yet, but I'm just going to start talking. Uh, we are live. So right now I'm trying to share the Facebook link with the world. Got the Zoom link, putting it into the meetup invitation. And that will go out to everyone. I'm not sure who's listening yet, but I'm just going to start talking. We are live. So right now I'm needed to mute my audio there. I'm getting the Facebook audio with a little bit of a delay. So welcome. I hope you can hear me. It looks like we've got a thumbs up there off to the right. Maybe throw a little comment in the chat there to let me know that you can hear me talking. Sending this out to everyone on the meetup list. And why don't we go ahead and throw this into LinkedIn too. Hey, Alberta, thanks for letting me know. Great. And I'm going to throw this into LinkedIn. Sorry for jumping around a lot. I hope that doesn't make you queasy. We'll stop doing it in just a minute. We'll settle down if we get everyone joined here for the webinar. We're going to officially start in 3 minutes. I'm just throwing links up in all the social media channels and everything. All right. And we'll throw it up, show the Zoom link up too. If you're interested in how I'm doing this, I'm actually using Zoom. They have an advanced feature where you can do webinars and it automatically links with Facebook Live. So it's super easy. Really, it does cost money, unfortunately, but it was really easy. So that would be something you can ask me about later on if you are interested in that, interested in doing webinars for yourself. Okay. So 11:58, we will officially get started in a few minutes. Let me actually send the link to the GitHub repository out as well. We're still working from the compound data types repo that we worked from a few weeks ago. This is a follow-up to that one. We sort of, when I say we, I lost that one. Missed a few weeks with some stuff going on, but we are back, and we're gonna have some fun with Python today. So, thanks everyone for joining. So yeah, we are actually going to be continuing with sets here, just like we did last time, the compound data type sets. So yeah, I hope you enjoy sets as much as I do. I'm not going to be running a Jupyter Notebook server this time, so you will have to run Jupyter Notebook yourself locally if you wanted to run the code. That might be something that I do again in the future, but I'm not going to be doing it for this particular session right here. So don't hate me. Well, not for that. All right, so it's noon. Let's go ahead and get started. We are working from a Jupyter notebook. Let me actually make this bigger. We're working from a Jupyter notebook that comes from the Compound Data Types repository at the Data Science Practicum GitHub account. So I've got this Compound Data Types repo that I'm working from. And Compound Data Types is the sort of the overarching topic that I'm interested in looking at right now. While I'm doing, while we're having this Fun with Python series, I'm interested in thinking about the primitive data types that are available in Python that are compound data types that have more than one value. So, your basic primitive data types are integers and floats and booleans, those sorts of things. But lists and sets and tuples are primitive data types as well. The difference is that those are compound data types. They have multiple values associated with each stored value. So, and in my thinking, the way that I'm thinking about it, sets are the least complicated of the compound data types. They have the least requirements, so I wanted to start with sets. So I'm going to hop over here to Jupyter. I'm running a Jupyter server here. I've got these two notebooks. This is the one that we did previously on the 20th of July. We're going to hop in on part 2 here for August 10th. So let's go ahead and open that one up. So some of this is going to be review from last time. We've got compound data types here. And I'm going to be making use of assertion statements. We talked about this last time, but the idea of an assertion statement is it's going to introduce a failure message if the statement evaluates to false. So if it evaluates to true, it's going to do nothing. So we see I ran this block of code, I assert true, and of course, true is always true, so it does nothing. So it keeps going. Now, if it evaluates to false, it's going to raise an error message of type assertion, or it's going to raise an error of type assertion error and give an error message that is going to be this message I'm giving here. So false is going to raise an assertion error and give us the statement, this is false, because that's what I told it to do. So, you might imagine doing it, doing something like this. In a very trivial way, we could assert that 1 is equal to 1. And of course, 1 does equal 1. That's going to be true, so nothing happens. But then if I do 1 equals 2, obviously that's not true. That's a false statement. So it throws an assertion error. And what I'm doing here is putting this into a try except and capturing the assertion error when it happens and printing the error message. And of course, if I'm going to do that, I need to give it an error message. So I'm giving it the message, of course, 1 is not equal to 2. Duh. And there we go. We get that message spit out for us. All right. So the data type that we're looking at here is the set. One thing that I like about sets is that they have a mathematical meaning in addition to a Pythonic meaning. And if you've never heard that word before, yes, Pythonic is a word. So we're actually going to be looking at sets in both senses, both in this math sense and in this Pythonic sense. So it's a built-in data type in Python. So if I request the type of a set, it tells me it's a type. In terms of math, a set is a collection of distinct or unique objects, which gives us the two basic properties of a set. A set is composed of elements, so it is a compound data type, which is what we're interested in looking at here. And the important thing is that each of the elements is unique. So I haven't defined A, B, and C here. We need A equals 1, B equals 2.4, and C equals, say, 3 plus 3j. So if I define this here, now I have a set A, and 1 is an element in A. So this assertion statement is going to evaluate to true. So I'm asserting that 1 is in A, and it is in A. We know that. So that evaluates to true and nothing happens. So if I look at A, we can actually see 1 is right there. Now, the other idea that we can think about with sets, and this is review from last time, but it's good to think about these things, is the idea of the cardinality. So the cardinality, it's a fancy word. The cardinality of a set just means how many things are in the set. So A has 3 elements, which is sort of weird. Because look, if you look back up here, I said A has 4 elements. But remember that sets are defined by uniqueness. So B and 2.4 are the same thing. So B is 2.4. So A is not going to count 2.4 twice, even though in my definition, I said A is A, B, 2.4, and C. It's only counting it once because sets are defined by uniqueness. So, this is the basic properties of sets. But what's more interesting for working with Python and for doing programming is actually building sets. So mathematically, there are 3 ways to build sets. You can build a set by explicitly listing the members of the set. So, we use curly braces to define a set. These guys right here. This is the curly brace. So we use curly braces to define a set. And here I'm saying that 1, 3, and 5 are in this set. I'm explicitly listing the members. Another way to define a set is to think about some property that a set might have. For example, I might want the set of odd positive numbers that are less than 100. So I could express that by saying that we have the set of numbers that are greater than 0, less than 100, and the number is odd. So this little bar right here, when I read that, that's sort of math speak for such that. So I would read this as n such that 0 is less than n, which is less than 100, and n is odd. So we're selecting from a larger, we could select from a larger base set. We could say that n is an integer, and 0 is less than n, which is less than 100, and n is odd. The third way that we could do this is that we could define a set using operators like unions, intersections, and difference operators. So the first method, where we explicitly define a set, is called the roster method. So we might want the set that contains the numbers 4, 15, 21, and 37, and here I'm defining that using the roster method. I'm listing the roster of the set. So it's worth noting that here I'm listing them this way: 15, 4, 37, and 21. But I can assert that 4, 15, 21, and 37 is equal to B, and this is true because sets don't actually care about the order of things. All sets care about are uniqueness and the fact that something is a member of the set. That's all they care about. So this is the roster method that I'm using right here. The next method that we'll think about is using set builder notation. So this is the second method that we were talking about, and here we've got, instead of doing less than 100, I'm doing less than 10 now here. So we're saying n such that 0 is less than n, which is less than 10, and n is odd. And I can do this in Python using a set comprehension. So I'm saying n, for n in the range 10, which if you're not familiar with what range 10 is, this is range 10. It's the numbers from 0 to 9. So from 0 to 10, not including 10. So n for the numbers in range 10 if n mod 2 is equal to 1. And if you're not familiar with mod, 5 mod 2 is equal to 1. So mod is the remainder when we divide by this number. So that's defining by set builder notation. And the last way we can define sets is by using operators. So we've got the set B that we defined earlier, and we can define a new set C, which is the union between B and some new set that contains the number 12 only. So in Python, we can do C is equal to B.union and the set containing the number 12. So what I want to do next is sort of think about these different ways of building sets and try to connect building sets with unions to building sets with set builder notation. So you can think about this by using a for loop to build some larger set. So I might try to expand on B by building a new union at each step in a loop. So what I'm doing here is I'm looping through this set that contains 12, 25, and 39. And as I'm looping through it, I'm grabbing the number at each loop using the variable L, short for element. And I'm creating a new set that's the union of B with the set containing that element at each pass. So before we actually run it, let's think about what's happening in this for loop. At each pass through, it's grabbing the number from the set so that it can work with it. So it first grabs, well, this is interesting. Look, it grabbed 25 first. That's because, remember, order is not important to sets. Sets have no order. So it could grab any number first. It could grab them in any order. We can't count on the order. So we're looping through we're going through the loop, and we're grabbing each of the numbers in the set and using them at each pass. And what we're going to do is create a new set that's the union of the original with the new set. And in the end, we will have a new set that is this guy combined with this guy. I mean, obviously, there's an easier way to do that. Just, just doing the union of this set and this set. But what I want you to think about here is not necessarily the easiest way to do it, but think about iterating through sets. Think about taking this set 12, 25, and 39 and grabbing each element of it as we move through the set and doing something with that. Because this is much more interesting when we have a pattern for the set that we want to loop through. So let's say that I have the set D, which is the numbers from 1 to 10. I could also have made that with the range from 1 to 11 and making a set from it. See, it's the same set. So I've got the set D, and now I'm making E is an empty set. And then for each element in D, I had to change that from my set to D. So if you're running this yourself, you're going to have to do that. So for each element in D, I am adding that element to E by multiplying it by 2 and adding 1. And so here's E. And if you look at the elements of E, you can see that each one is 2 times an element in D and added 1. So, maybe if you were thinking about some function, it might be 2x plus 1. I want you to think about this in terms of this for loop that I'm building right here. I'm looping through the set each time, and I'm grabbing an element from D. So I'm grabbing the elements from 1 to 10. And then I'm multiplying it by 2 and adding 1. And I'm adding it, I'm unioning that number with the set E to build this larger set E that's 2x plus 1 over D. Now, again, there's an easier way to do this. I'm going slowly because I want you to think about what's happening when we build with this set builder notation. So what we're ultimately doing is we want E is 2x plus 1 such that x is an element of D. And we can do that in Python using our list comprehension syntax. We can simply say that D is the numbers from 1 to 10, and E is 2 times x plus 1 for x in D. And obviously, this is a lot easier to read than this, but this might be conceptually new for you, the idea of a set comprehension. Now, what I really like, being someone with a background in math, what I really like is that this set comprehension syntax mirrors the set builder notation that we have when we write this in math, this guy right here. So this is all really abstract, and you might be going, great, what are sets even for? Like, why would I even need this? So what I want to do next is just take a brief moment to look at, it's a simple made up case study, but it sort of shows how we might use sets. So let's say that some company is recruiting students from a university to give them jobs. So what the company wants to do is interview fourth year students who are either computer science or electrical engineering students and who have a grade average of B or better. So let's suppose that we have data files for these students. And actually, if you look back here, we actually have these files right here. So we've got cs.txt, ee.txt, goodgrades.txt, and year4.txt. And these are lists of students that maybe we've pulled from the university database that meet these different criteria. So this is a list of students who have good grades, which is a grade average of B or better. Oh, look, there's Josh on the list. Yay. All right, so we have these lists of students. Here's the CS majors. Here's the EE majors. So what we want to do is create a list that we can give to the employer that is students who are either CS or EE that are in their fourth year, they're getting ready to graduate, and that have good grades. So, we might think about a structure for solving this problem where first we read the inputs, then we do the computation on the inputs, and then finally we display the results that we need. So let's start by reading the inputs. And we can do this with a for loop. So what we've got here is we're going to open the year4.txt file for reading, and we're going to give it the name the file. And then we're going to make an empty list called year4. So, and this is sort of, if programming is something that's new for you, this might be something that's a little bit tricky to think about, right? We've got a file called year4, and now we've got a variable in Python called year4 that's going to be a list of numbers. Or I'm sorry, a list of names, a list of student names. So these are two separate things that we need to keep track of, and this is how we're going to be doing, this is how we're going to program to solve this problem. So we're going to open the year4.txt file, give it the name the file, and then for each line in the file, we're going to append the line to the list year4. And what this dot strip is going to do is remove the line breaks at the end of the line. If that was confusing, you don't need to worry about it. Just take my word for it, it's useful. So what we're doing is we're creating this year4 list, and here I'm going to display the first 5 elements in the list after I make it. So these are the first 5 year 4 students in the file year4.txt. So Leanne, David, Danny, Aaron, and Bradley. And if I hop back over here and take a look at my year4.txt file, you can see that in fact, those are the first 5 lines from the file. And what we've done is we've read them into Python. They're actually here in our Python session for looking at. So we can look at, student 0 should be Leanne, year 4. And then, student, so 0 is Leanne, 1 is David, 2 is Danny, 3 is Aaron. So year 4, student 3 is Aaron. And we've got the year 4 students saved in memory. We've read them into our memory. So this method here, well, beyond being kind of hard to read, it's a little hard to read, right? I'm looking at this and I gotta like think, like, what's going on here? A lot of programming. There's actually an easier way to do it that's easier to read. And it's using this, these comprehensions that we've been looking at. So year 4 is gonna be line.strip for line in open year4.txt. I think that this syntax here is a lot easier to read. I don't have to figure out what's happening here. I don't need a comment to tell me what the code is doing. I can look right at it and I can tell that year 4 is going to be each line in the file year4.txt. And CS is going to be each line in the file cs.txt, and so on and so forth. And here we can display maybe the first 5 students in EE, Shane, Connor, Helen, Nicole, and Callum. And we can look at the ee.txt file, and in fact, yep, those are the first 5 students there. So the code looks like the code's doing what we expect it to do. So we have what we set out to do at first is read the inputs. We have read all the inputs, and we have everyone stored in memory now, year 4, CS, EE, and good grades. So the next thing that we want to do is the computation. Remember, the problem that we're trying to solve is 4th year students who are either computer science or electrical engineering students and who have a grade average of B or better. So here's a way we might solve this in Python. So we might make an empty list called candidates. And then for each student in year 4, so each student in the year 4 list, if the student is in the CS list or the student is in the EE list, so this is a whole compound statement right here, right? They could be either CS or EE. And so after we figure out what if the students are in those 2 lists, and they're in the good grades list, then we're going to append them to the empty candidates list. And we're going to wind up with a list of students who are 4th year, either CS or EE, and have good grades, which is what we wanted. So we've solved the problem, right? This is a solution to the problem we set out to solve. And there it is. These are the students that that meet the requirements we have. And maybe, maybe it's a big list. Maybe let's just look at the first 5 of them. So here's the first 5 students that make the cut. Jasmine, Callum, Dale, Shane, and Kaylee make the cut. So being a good computer scientist, I know that we can do this more efficiently with sets. Sets actually require less overhead than lists do. So to start out, let's actually go back and reread everything. And instead of reading them as lists, we're going to read them as sets. And all we had to do is change before we had in brackets. We had this in brackets before, which if you're not familiar, that's a bracket, that's a brace. So we had it in brackets before, and that created a list. So if we put it into braces, that creates a set. So now when I load this in, instead of being lists, here, I'll show you before I load it, year 4 is a list. Maybe I'll show you EE for comparison. EE is a list. Now we run it, we load it again, And now EE is a set. So we've done the same thing, but we're telling it I want it to be a set instead of a list. And then we're going to solve the problem the exact same way. Candidates is an empty set. Then for each student in the year 4 set, if the student is in the CS set or in the EE set, and the student is in the good grades, we're going to add it to the candidates set. And here we are. We've got our list of students, but again, that's a bit long. So why don't I do this real fast? I'm going to import random, and I'm going to just do a random sample of the candidates, and we'll take 5 of them. A random sample of 5 candidates. So Ben, Sean, Reese, Amy, and Peter made the cut. But again, this is a bit complicated. We're using these for loops, big if statements. There's actually an easier way to do this. Since we're working with sets, we actually can use the idea of sets to work on this. So here I'm actually going to just build the set from the different criteria that I have. So I'm saying for student in year 4, using my set builder or set comprehension notation. So if I just do this, I mean, that's basically just the year 4 set, right? So I can assert candidates equals year 4. Yep, they're identical. So I don't just want year 4 students, I actually want some restrictions. So I'm going to start with the year 4 students, and then I'm going to add these criteria. So students, for student in year 4, if they're either in the CS list, CS set, or the EE set, and the students have good grades. And now I have a new candidates list. Let's grab this random sample guy up here. It's going to be a different random sample of 5, but we've got it restricted. And in fact, it looks like Amy made it in to our random sample both times. You know, one other thing that we can check just to make sure that they're the same is we can actually, we can print the length of candidates after we run it this way. And it's 25 students. And we can print the length of the candidates list after we run it this way, 25 students. So these two methods, doing the calculation this way is equivalent to doing the calculation this way. And I think that this one reads a lot better than this one. I might need some comments to tell me exactly what's happening here. But here I can look at it and it reads almost like English. This is one of the advantages of working in Python. It's very much close to English. Now, I actually know there's even an easier way to do this using union operators and, intersection operators and union operators. So what I'm going to say is that candidates is the year 4 students that are also in CS or EE and have good grades. And this is going to give us the exact same thing. So here, let's get the list, let's get the length, and let's get a sample. And yep, there we go. We've got 25 students, and we've got a random sample from the list. So this technique is showing you a use case for working with sets. What we want is, we sort of want, we can imagine a Venn diagram for working with this, right? So we would have, you know what? Here, let's do this. Let's pop open Keynote, and we can actually draw a Venn diagram real quick. So I'm going to stop the Safari share, and I'm going to share this empty Keynote presentation. So what we're talking about here is we've got, so we might have the year 4 set, You know, maybe we can draw that as like, you know, some circle of students. And then we've got the CS students. And then we've got the EE students. And then we've got good grades. So, and you know what, let's make these guys a little bit transparent so they can overlap a little bit and maybe make them different colors just for being fancy. And then that makes the, here, maybe yellow is bad for that one. How about turquoise? There we go. Okay, so what we're talking about is students that are in year 4. So we're starting from that and have good grades. So we want sort of the overlap of year 4 and good grades. So they have to have both. And maybe, you know, actually, you know, probably be like this, right? There's students who have good grades who aren't in year 4 and students who have good grades and are in year 4. And actually the year 4 list was a lot bigger. I'm sorry, the good grades list was a lot bigger than the year 4 list. So we've got students who are in year 4 and have good grades. Now we've got students who are, these are actually independent of each other. No one's an EE major and a CS major, or maybe someone is, but for this case, maybe they're not. So what we're talking about here is students, let's make these really small so we can fit them in there. So what we're talking about is students that major in EE or CS, have good grades, and are in year 4. So we're talking about this group right here. Here, let me actually see if I can draw it with one of these guys. Not that. This guy right here. Yeah, there we go. So we're talking about these guys right here. And we're talking about these guys right here. Here, let's give these guys their own color. How about here, we'll make them pink. And we'll make them, they're not, well, whatever, you got it. We're looking for these guys right here and these guys right here. Now, we did this in Python. Here, let's do this. Let's throw this back in our notebook so we can look at it. All right. And I'm going to hop back over here to my notebook, reshare that. There it is. All right. So in Jupyter Notebooks, if you have a URL for an image, which I did by putting it on Evernote real quick, you can just pop it into your notebook just like that. So here we go. We've got this Venn diagram that we're looking at. We want year 4 students who are in CS or EE and have good grades. And it's these two little wedges right here. And we were able to grab it in Python by just using this very simple syntax. Now we were able to use this because each of these year 4, CS, and EE and good grades are sets. So the takeaway is that sets are awesome. I hope that you learned a little bit about Python and sets and that you had, enjoyed this session. If you have any questions, you can go ahead and throw them into the Facebook session or Zoom if you have joined there. But I haven't got anything else. So I'm gonna give you a chance to ask a question, and if not, we will hop off and maybe I will see you later in real life. All right, just giving a second to see if there's any questions popping up. We will hop off and maybe I will see. All right, well, thanks for joining in. And we'll be doing another one of these next week, and maybe we'll move on from sets and move on to more interesting things like lists. But until then, thanks for tuning in, and I will see you later.